This is A Small Dose of Hope Can Bring Us Together. Welcome, I'm Francesca Hawkins. Presented by the ANSA McAL Group each week, our guests on the show are international, regional, and local experts, all medical specialists functioning on the front lines of the COVID-19 pandemic. And tonight, our guest is a son of the soil who is now established at one of the world's foremost medical institutions, where he is both a medical practitioner and a scientific researcher, with his primary focus on virology and immunology. His clinical practice focuses on patients with chronic infections such as HIV, hepatitis B and C, and patients born with or those who have developed immune system deficiencies. Recently, he's also expanded to care for patients with COVID-19 infections. This eminent doctor received his Ph.D. in immunology with a graduate thesis focused on the development of DNA vaccines for HIV and other viruses. Dr. Michael Chattergoon is the R. Meyerhoff Assistant Professor of Medicine at the Division of Infectious Diseases at the Johns Hopkins University in Baltimore, where he directs an active laboratory. Thank you so much for giving us your time, Dr. Chattergoon.
Thank you very much. Thank you very much. Happy to be here.
It's a pleasure to have you. First question. Scarcity of the vaccine is an increasing concern worldwide. Right here in Trinidad and Tobago, for example, our own allocation from the WHO's COVAX facility has now been cut back to about 1/3 of our initial allocation. Given this challenge of supply, how do you see this impacting on public health as it unfolds locally and also internationally, Dr. Chattergoon?
Well, your question really hits at the heart of the matter. We now have several different vaccines that are available to us, and for the most part, the vaccines are all proving to be pretty effective at the current coronavirus that is circulating around. As you know, there are some strains that are emerging that are becoming problematic. Now, one of the things that has also become apparent during the rollout of the vaccines is the inequity in the rollout. The head of the World Health Organization, Dr. Ghebreyesus, 2 months ago or so, in the middle of January, put out a statement, to the effect that they had observed that in the richest countries in the world, at that time, up to 40 million people or so had already been vaccinated. And in other countries, there were no vaccines or very few vaccines. And he really, I think, spoke to the idea that the equity of distribution was not just a moral issue, but also a medical issue, an economic issue. And I think the way we need to look at it is really, if we distribute the vaccine in such a way that we protect one little corner of the world, one group of people, and we don't adequately distribute vaccines to other folks around the world, the epidemic is going to go on, and new variants are going to emerge in different places, and ultimately even the vaccines we have may not be effective. So it really is the case that we really need to make efforts to try to distribute the vaccine as much as possible. Now, on the other side of the equation, there's issues about the supply of the vaccines. It's just physically, it just takes a certain amount of time to make vaccines. And some of the vaccines have specific requirements about how they can be shipped and temperatures and, all sorts of variables and logistical issues. So, I think the variable and logistical issues, they could be solved, but I think really ensuring that there's equitable distribution of vaccine is really something that needs to be a priority for our leaders. And the folks.
Do you think, given the problems you've outlined, that global collaboration between scientists can really achieve the, for example, COVAX target of 2 billion vaccines by the end of the year? Is that realistic? Can collaboration really solve this problem as you're describing?
Well, I think collaboration and cooperation. I think the scale of production that we need for these vaccines is really something that has to be coordinated at a fairly high level, governmental level, and cooperation with some of our larger pharmaceutical companies, because they're really the only folks that have the capacity to manufacture these vaccines at the scales that we need to have available. So, I think those targets are optimistic. I think they're achievable, but they are going to require a good amount of cooperation to get those done. And we have to ask, who really has the ability to pull together cooperation from, such a diverse group of companies and individuals that are in different parts of the world that are, maybe have slightly different agendas. And I think it really has to come from leaders like WHO, COVAX, governments, et cetera.
Now, immunology is your field of advanced specialization. What is your assessment of the efficacy of the new COVID-19 vaccines, especially as you touched on earlier about this really serious threat of mutations?
As a person who's worked in vaccine development for a number of years now, I would say that the development of the coronavirus vaccines that we have is probably nothing short of miraculous. And, it really kind of comes in two ways. First, we're all probably familiar with the mRNA vaccines. Those were the first vaccines that were licensed in the United States from the companies Moderna and Pfizer. And those actually represent a brand new vaccine technology that had never been used on a wide scale in humans before. Yet they're working fabulously, up well over 90% of individuals who get the vaccine are protected. Some of the other vaccine technologies, for instance, the AstraZeneca Oxford vaccine, they're working maybe at a slight tick lower in efficacy, but they're still very effective. And I think the most amazing thing is really how quickly they were developed. Prior to this COVID epidemic here, the fastest that we had ever generated a vaccine and widely distributed it was, measured in decades and not in months. So I think these vaccines are amazing, both from their strong efficacy and also from how quickly they were developed and distributed, which I think, again, speaks to cooperation between scientists around the world.
Now, one interview I had recently with our Minister of Health here in Trinidad, he indicated that one of the government's aim is to eventually offer a suite of vaccine options here in the public. He mentioned the Chinese vaccine could be one of the options on the table. What can you tell us about the Chinese vaccines so far?
Yeah, so, there have been different vaccines that have been developed. The Chinese vaccine is a vaccine that was developed by taking or purifying the actual virus itself, doing a series of chemical modifications and steps to essentially kill that vaccine, to basically make it inert so that it could not replicate. And then that material is then basically used as the vaccine. And when that is injected, it tricks your immune system into thinking that you have been infected with the COVID virus, with the SARS virus, and you generate an immune response. And really, it is probably one of the oldest vaccine technologies that we have had. Many of our older vaccines, like the older forms of the flu vaccine, et cetera, were made in exactly this way. Some of the other vaccines, like the ones I mentioned with the Moderna or even the AstraZeneca vaccine, they use newer technologies where a small gene of the virus, and I remember the virus itself can make 25, 26 different proteins. So they just took one of those and put it into another virus. And they're using this virus basically to deliver that gene of the coronavirus into your system. So they're safe. The vaccine only carries one protein, so there's no chance of getting COVID from the vaccine. And it seems to be very effective at generating a strong immune response that is protective. So different techniques have been used, but they seem to be working pretty well. there's even, some talk right now, and this goes back a little bit to your question about the scarcity of vaccines. Currently, all the vaccines we have and all the trials have been, say you get 2 doses of the same vaccine. So, you may get 2 doses of the Moderna vaccine, 2 doses of the AstraZeneca vaccine or whatever. But there's some talk now that maybe that might not be the optimal strategy. Maybe you get your first shot with one manufacturer vaccine, a second with another, and that could help alleviate some of the issues with supply of vaccine. Because if you can get an initial shot with one manufacturer, a second shot with another, maybe that would facilitate a better distribution of vaccines. And that exact question is being tested in a clinical trial that is about to begin soon.
Doctor, new data is showing that women in particular are facing extreme stress during this pandemic. You're an immunologist, you've got broad experience, you've worked on HIV, AIDS, infections, hepatitis B and C. Can you explain the connections between sex and gender within the context of either an epidemic or a pandemic, and how should we be aware as a society of the effects on women and as individual women in the context of this pandemic?
Yeah, and that's an interesting question. So we have long known that for some of the viruses that we have been treating for a long time, that there is a difference in the outcome of treatment or the ability of the immune system to deal with that infection, depending on the sex of the person. So an example, for instance, is hepatitis C that I deal with frequently. You are more likely to clear the vaccine on your own if you're a woman, particularly if you're a young woman. Whereas other groups of people are less likely to clear the vaccine. Similar sort of things also happen in HIV, where treatment outcomes can be different depending on the sex of the person. So one of the things that has been seen with COVID is that male gender or male sex is a risk factor for more severe illness. So, if you take an equally matched group, as best as you can match them based on, age and other diseases that they may have, that males typically have a worse, or I shouldn't say typically, males are more likely to have a worse outcome than females.
So is the data that is showing that women are under greater levels of stress because women are the caregivers, or women are now being forced to provide extra income and so on, when possibly there is a higher incidence of acute infection amongst males?
No, I think what you're pointing to is one of the things that we always grapple with is the difference between what is being driven by biology and then what is being driven by this sort of social context in which this is happening. So I think you are correct that generally women bear the brunt of most infectious diseases because they're really the core of the family. And I've seen many patients where I'm dealing with like a middle-aged woman, and she's clearly sick and maybe needs to be in the hospital for a couple more days, but is anxious to get out of the hospital because there's things to tend to at home, and or maybe needs to go to a job or something, and that certainly leads to less than optimal outcomes for these diseases. So I think that's one aspect of it. But then the other aspect is from the standpoint of the biology of the person. Do hormones that are associated with different sexes lead to different outcomes of infection? We know that there are slight differences in the immune system between men and women. Do those really impact on the outcomes of infections? And those are things that are still actively being investigated as to how that is going to impact on COVID.
Thank you so much. You're watching A Small Dose of Hope Can Bring Us Together. Our series brings you the very latest information on the new COVID-19 vaccine, explained by scientists, medical leaders, specialists, and practitioners based in Trinidad and Tobago, the region, and internationally. Our guest is a son of the soil, now established at one of the world's foremost medical institutions, where he is both a medical practitioner and a scientific researcher, with his primary focus on virology and immunology. Dr. Chattergoon, at the research laboratory that you lead at the Division of Infectious Diseases at the Johns Hopkins School of Medicine, one of your areas of focus is innate immunology, which investigates why the immune system fails to clear some infectious diseases. With respect to COVID-19, what are your findings in this particular area?
Yeah, so, maybe the first thing I should say is that very quickly at Johns Hopkins, a collaborative effort developed amongst many of the scientists here at Hopkins who are world experts in virology and immunology and various aspects of medicine. And that was really organized and driven from the leadership of our hospital. My particular area of interest is really a small part of that, and that is really about innate immunity. I think the way to think about that, and maybe the way I'll explain it to your audience, is that when we first get an infection, the first barrier to infection that a virus or a bacteria would meet is the innate immune system. And this is kind of the more primitive part of our immune system. But it is ready to go at all times. It's pretty much always active and is ready to go. And so, one way to look at this is that the virus must have a pretty efficient way to escape or to get around that first barrier, to infection in order to be able to set up infections. And so we are working on trying to understand how the virus escapes that first roadblock that is set up. There have been some findings that one particular arm of the innate immune system, the virus has several proteins that counteract that function. And so we're beginning to see that the virus actually has some built-in defenses that I'm sure developed evolutionarily to give it the advantage to infect us by suppressing parts of the innate immune system. So we are involved in trying to understand the innate immune system and then trying to understand how the virus gets around it.
Have you encountered patients who are dealing with what's called the long COVID? What can you tell us about this phenomenon?
Yeah, we have I've seen some of these folks. There's sort of two types of patients, I think. So there are some patients who seem to have a hard time actually clearing the virus out of their body. And we can tell that because we can do, the test that we do for diagnosing the virus, we can do that at multiple intervals. And we can find that some of these, that we're finding some people that have problems actually getting rid of the virus. But then there's another category of patients who, as far as we can tell, the virus is gone from their system. We can't find the virus in their system, but yet they continue to experience symptoms that are persistent. And in my experience, the symptoms range from psychological symptoms, depression, fatigue, things like that. And then there are some folks who have, real sort of biologic symptoms. Their respiratory state never returns to what it was before they got COVID. Sometimes there's other sort of unusual things that happen. So I think their efforts right now just recently started at many institutions and something that the National Institutes of Health in the US is interested in trying to describe this syndrome more clearly and to try to understand the biologic basis of it. But I think it seems that it is pretty clear that a certain group of people continue to experience symptoms after clearing the virus, and that these symptoms could be pretty widely ranging from you know things that they experience physically to things that they experience psychologically.
Now, in terms of the new mutations, are you optimistic that we will be able to find upgraded vaccines as quickly as the COVID-19 vaccine was developed? What is your view on treatments which will block or stymie infections by the new mutations?
Mm-hmm. Well, that's maybe I'll answer that in two parts. So, as you know, there are three variants that are particularly concerning. They're actually called variants of concern. And even though variants have been emerging, pretty much since day one of the COVID pandemic, these three variants seem to have locked in, and they're expanding fairly rapidly. In particular, the one that is referred to as the UK variant is expanding pretty rapidly in different parts of the world. Ultimately, how do these variants come about? The virus can only make mutations when it is replicating. So every time the virus replicates is an opportunity for a new variant to come about. And then some of these variants are going to have an advantage. They're going to be better at spreading. They're going to be better at infecting a cell. They're going to have some advantage. And so eventually, some of these variants will begin to establish and take over. So it kind of comes back to the idea then that really the way to prevent variants from developing in the first place is to prevent replication from happening in the first place. And, the two ways, maybe we have three ways to deal with that. The first is all the things that we've been doing to sort of stay physically isolated and make it harder for the virus to spread between two people. The other is vaccines, because, the more vaccinated people we have, the less chance that new people get infected and less chance for new variants. And the third is some of the drugs that we've developed. We have one antiviral drug, remdesivir, that's been developed, and there's a new drug that is being evaluated right now. And my understanding is that the clinical trials for those drugs will shortly be over. So we may have another new antiviral. But the idea is basically that in order to stop variants from emerging, we need to do as much as we can to stop new infections. And this is really, the key to the vaccines. The more effectively
this brings us right back to maintaining all our protocols, masking, hand washing, social distancing, as well as looking for vaccinations in a timely manner of distribution. Now, in your practice and in dealing with patients with COVID-19, what, in your view, is some of the misinformation, some of the damaging misinformation that some of the population may have heard about both the virus and the vaccine, which you think is unhelpful? What would you like to highlight as some of that misinformation that we should all be educated about?
Yeah, well, I have a group of patients who, because of their other problems, their other immune deficiency problems, they are pretty vigilant about trying to prevent infections, not just COVID, all sorts of infections. And so, one of the things I've seen amongst new patients that I've taken on recently is this idea about doing what we can to really prevent the spread of the vaccine. And I think, not that I think people don't understand that hand washing and physical distancing and masking is important, but I think, there's a certain amount of fatigue that comes with that. We've been doing this for about a year now. In fact, I think today is probably the anniversary of the first case of COVID we had in Maryland, where I am. But we get fatigued about that, and I think keep communicating to folks that we need to sort of keep that up as a major method of prevention is a message that I have to continue to give patients. There's all sorts of issues and misinformation around the vaccines, not just the COVID vaccine, but even other vaccines. There are many people who fear that they may get COVID from the vaccine, which is not the case because, as I mentioned before, the vaccine really only contains a very small portion of the virus that is not able to replicate on its own. There are many people who have this conception that the side effects of the vaccine are worse than getting COVID. And this is clearly not the case also. But I think one of the things that is key to communicate is, many folks feel that, well, I can protect myself from getting COVID. I can keep myself isolated. I can, do whatever measures I need to do. So why do I need to get a vaccine? And I think, we need to recognize that when we get a vaccine for ourselves, we're not just protecting ourselves, we're protecting all the people around us. We're protecting the group of people who, for one reason or another, can't get one of these vaccines. We're protecting all the kids who, right now are not candidates for vaccines. So one of the things that I always try to stress a lot is that, getting the vaccine is not just for you, it's for your community. And I think trying to get that message across is, to me, one of the key things about, trying to improve the uptake of the vaccine and convincing folks that this is the way to really try to get ahead of this pandemic.
Dr. Chattergoon, thank you so much for joining us. It's been a real pleasure. We're in the final moments of our time together. Can you share with us your final thoughts, and do you have a prediction about the time it might take to get the world to exit the pandemic?
Yes, well, I think that, if I could convey a message, which is that, we have been successful at eradicating some infections, from the earth. But really that has never been done without a successful vaccine. So we now, we stand at a point now where we have some vaccines that are successful, and, hopefully we can get these distributed quickly enough. The task we're facing is monumental. History will tell us, we can look to our own history. When we eradicated smallpox from Earth, that took many years of a dedicated vaccine initiative, to really go to the last corners of the Earth to get to vaccinate folks. And, you can think about how monumental the task is. We're really saying, to really get out of this epidemic, we really need to get the majority of the world vaccinated as quickly as possible, ideally even within the next couple of months. So the task is monumental from many different areas. But, the other message I would say is, when your opportunity comes up to be vaccinated, get the vaccine, because you're helping yourself and you're helping your community. And even if one person out of 50 is vaccinated, that's still less of an opportunity for the virus to move around the community and cause disease. So when your chance comes up to be vaccinated, please get the vaccine, and you'll be helping to get us out of this.
Thank you so much, Dr. Chattergoon. Of course, your closing message there is the vaccination remains our best chance to exit this pandemic. Joining us from the Johns Hopkins Center Infectious Diseases in Baltimore, this has been A Small Dose of Hope Can Bring Us Together, a series on the COVID-19 vaccine presented by the ANSA McAL Group. We plan to continue this series in the coming weeks when our conversations on public health continue. I'm Francesca Hawkins. See you next time.